Have you ever wondered why it's so tricky to push a heavy box across the floor, or how we stop ourselves from slipping? Today, let's dive into the world of friction, a magical force that's always at play. Friction is a force that happens whenever two things rub against each other. It's the invisible tug that tries to stop things from sliding, keeping us safe, and sometimes making us work a bit harder. Imagine trying to slide your shoes across a smooth wooden floor. Easier than on a rough, carpeted one, isn't it? That's friction in action. Meet Max the monkey and Izzy the inventor. Max loves to slide down the banister, but Izzy wonders, why doesn't he zoom down like a rocket? The reason is friction, which helps Max slow down so he doesn't crash. There are two main types of friction. First, there's static friction. Static friction is like a stubborn guard that won't let things move at all. Imagine you're trying to push a heavy box. At first, it doesn't budge. That's static friction, pushing back, keeping the box in place. You have to push really hard to get it moving. Then comes kinetic friction, also called sliding friction. Once that box starts to move, kinetic friction steps in. It's a bit weaker than static friction, but still works hard to slow things down as they slide. So when Max's shoes glide across the floor, kinetic friction is working to gradually bring him to a stop. Let's see the numbers. To figure out how strong static friction is, scientists use a formula, F less than or equal to mu times N. Don't worry if it looks tricky. F is the force of static friction. Imagine how hard you need to push. The squiggly letter, mu, pronounced mu-s, tells us how grippy the surfaces are. N is the weight pressing down on the surfaces, like the box's weight. So, if the surfaces are rough, mu is big, and friction is strong. Once the box budges, we switch to the kinetic friction formula. F equals mu times N. F is the force of kinetic friction, how much the box slows down while sliding. Here, mu k, tells us how slippery things are when moving. The heavier the box or the rougher the surface, the more friction you get. What's a real-life example? Imagine pushing a box across your garden patio. At first, you'll have to push hard, static friction. The moment it shifts, it's a bit easier to keep it moving, kinetic friction takes over. Or think of sliding your trainers on grass versus ice. Much easier to slip on ice, because ice has less friction than grass. With Izzy's colorful meter, we can see static friction stand tall at the start, shrinking away as the box moves and kinetic friction takes charge. Max and Izzy soon discover that friction isn't just a bother, it helps us walk, drive, write, and play. Without friction, everything would slide and slip everywhere. So next time you push, pull, or slide, remember friction is right there, lending a helping hand or a gentle tug every step of the way.